Welcome to our latest video, How Safe Are Pesticides? In today's episode, we unpack the truth behind pesticide use and its impact on the food we consume daily. Stay tuned to learn how to navigate a world rich in fruits and vegetables while keeping your health a priority. Don't forget to like, share, and subscribe. Pesticides are chemical substances or mixtures devised to manage, control, or eliminate harmful organisms such as insects, rodents, fungi, and weeds that threaten agricultural yields or human environments. The word pesticide stems from the Latin pestis, which means plague. Pesticides have broad applications, extending beyond agriculture to household usage, where they exist in various forms such as sprays and powders to mitigate pests like cockroaches, mosquitoes, and rats. There are approximately 1,600 distinct pesticides formulated into roughly 35,000 commercial products globally. This practice has historical roots. The ancient Romans utilized sulfur for pest control and employed salts, ashes, and bitter substances for weed management. Even in the 1600s, concoctions of honey and arsenic were utilized to manage ant populations. The significant advancement in pesticide development came in the period surrounding and following World War II, when numerous effective and affordable pesticides were synthesized and manufactured. However, despite their utility, pesticides present a considerable health risk. The World Health Organization estimates around 3 million cases of pesticide poisoning annually, resulting in over 250,000 deaths worldwide. The adverse effects range from short-term issues such as skin and eye irritation, headaches, and nausea, to long-term problems including cancer, asthma, and diabetes. Are all pesticides toxic, and to what extent? Some of them are. For instance, organophosphorus pesticides, initially developed as warfare agents, are highly toxic, yet they decompose rapidly when exposed to light, water, and varying temperatures. Therefore, adhering to the recommended waiting period post-spraying can effectively negate their harmful impacts. Contrastingly, organochlorine pesticides are less toxic but fat-soluble, leading to their accumulation in the fatty tissues of humans and animals. Thus, they account for about 90% of pesticide residues in food, a statistic reinforced by recent meta-analyses indicating a 30% increase in metabolic syndrome risks with heightened exposure to these substances. This correlation, driven by the pesticides' lipophilic properties and their affinity for adipose tissues, accentuates the crucial role adiposity plays in determining the detrimental health effects associated with pesticide exposure. A notable pesticide that has garnered infamy is DDT, despite its initial acclaim that even won Swiss scientist Paul Muller a Nobel Prize. Its adverse effects, including its tendency for biomagnification and inducing reproductive disorders in animals, were realized soon, leading to its ban in many countries. For example, agricultural runoff introduces DDT into aquatic ecosystems at levels of 0.0003 ppm. This substance is then absorbed by plankton, elevating the DDT concentration in their bodies to 0.04 ppm. As small fish consume the plankton, their bodies accumulate DDT levels of up to 5 ppm. This process escalates with larger fish who prey on smaller fish, resulting in DDT concentrations as high as 25 ppm in their systems. At the apex of the food chain, birds experience the highest accumulation, with DDT levels potentially exceeding 125 ppm. This process, called biomagnification, sees a stepwise increase in the concentration of substances through each trophic level. A significant repercussion of this is the weakening and thinning of bird eggshells, notably impacting species such as the bald eagle. The compromised eggshells often break during incubation, a factor that contributed to diminishing bird populations until stringent restrictions were placed on DDT use. Remarkably, DDT is still utilized in some regions for mosquito control, justified by the greater peril posed by malaria. This ongoing usage raises the pressing issue of pesticide dispersion through ecosystems, highlighting the ubiquitous presence of these substances, even in regions where they are banned. When discussing pesticides, many individuals instantly associate them with the residues found on fruits and vegetables. However, pesticides permeate more than just the produce aisle. They can be detected in water, air, soil, and various foods. These substances can leach from soils into water systems through precipitation, a process which allows them to persist in the environment for decades, circulating continually through natural habitats. Consequently, a large number of river streams in agricultural regions bear the burden of pesticide pollution. In locales with a high concentration of corn cultivation, the herbicide atrazine presents a significant concern. In fact, approximately 40% of sampled drinking water in these areas contains detectable levels of atrazine, exposing an estimated 33 million people in the USA to its potential effects. This pollution is primarily driven by runoff water transporting pesticides from fields into groundwater supplies, a primary source of drinking water for many communities. Thus, even if tap water meets sanitary standards, it is not guaranteed to be pesticide-free. Dr. Tyrone Hayes, a distinguished professor of integrative biology at the University of California, Berkeley, has spearheaded numerous studies on atrazine's biological impact, with a particular focus on its disruptive effects on amphibian endocrine systems. His research revealed that 10% of male frogs exposed to atrazine-contaminated waters exhibited feminization, possessing mixed gonads, and even demonstrating mating behaviors and reproductive capacities typically associated with female frogs. However, it is important to note that these findings have ignited substantial debate and are a topic of ongoing research and discussion. Currently, the primary individuals facing the adverse effects of pesticides are the farmers who adhere to stringent guidelines to safely handle, apply, and dispose of these chemicals. Yet, the scope of concern is broader, encompassing the escalating use of pesticides due to climate change and the development of pest resistance over time. Moreover, pesticides often exhibit non-selective effects, impacting non-target organisms, including beneficial fungi integral to soil health. In closing, it is imperative to consider the broader health implications associated with pesticide exposure. Between 1990 and 2019, there has been a startling increase in early-onset cancer cases by 79.1% and a 27.7% rise in early-onset cancer fatalities. Considering the fact that dietary risk factors, diet high in red meat, low in fruits, high in sodium and low in milk, are among the main risk factors underlying early-onset cancers, I would not recommend people to avoid fresh fruits and vegetables due to the fear of pesticides. Thank you for your attention. If you liked this video, please like and share this clip and consider subscribing to the channel to receive notifications about new videos on similar topics.